The question says, calculate the electric field due to a uniformly charged ring at a certain distance from the center on the axis of the ring. Also, find the maximum field. Now we'll take a point called as, say, O. This O is the center of the ring. We'll draw the axis and we need to find the field at a certain point. We'll call the point as P. The distance between this O to P is called as, say, we'll call as X. And let the radius of the ring be A. So we need to find what is the field at this point P, and the field and the ring is charged uniformly. Let the total charge on the ring be capital Q. Now what we'll do here is, since it has charge everywhere, we'll take a small part of the ring, a small element. Let the charge on this element be dq. Now this element would create a field at the point P, and this field would be going out of the element like this, but it is charged positively. So the field because of this would be in this direction, that I call as dE. So dE is the field which the small element is creating. Let this point to be A, this point is O, and distance between point A to O would be R. That's the radius of this, would be A, that is radius of this ring. Let the distance between A to P be R. The angle made here is theta. Now what we'll do here is, in this case, we'll find another small element which is exactly opposite to this element at A. So somewhere here we find one more element we call as at the point B, and even the charge on this, let it be dq. Now even this would create a field, and this field again would be outwards because it is charged positively. So field from here would be in this direction. It goes like this. This would be again field dE, and even this also would be theta only. The field because of this element and this element would be same in magnitude because the distances are same and also charge is same, but they are different directions. We'll first find what this dE itself is. Due to any one field, this dE would be, if you recall what is the electric field due to a point charge, the electric field is given as K Q by R square. In this case it will be K, the charge in these elements is taken as dq by distance square, which is AP or BP, which is R square in this case, is what is the distance. But these two fields are different directions. There's one field going like this and one field going like this, but they are same magnitude but different directions. To solve such problems, we will put an axis here, an axis like this, axis like this. We'll call this as x-axis, this as the y-axis. Since the angle made is theta here, even this would be theta, this also would be theta. So components of this would be dE cos theta along this direction, and this would be dE into sin theta in positive y direction. The components of this would be along positive x and negative y. So this component would be dE into cos theta, and its y component would be along negative y direction, which would be d into E into sin theta. So these two components would cancel each other, and what remains would be only the cos component. Now we get here, in this case it will be 2 into d into cos theta for these two elements, but a ring contains many such elements. For example, if we take one element here, there would be an element which is opposite to this element, such that even these two elements would create a field, and even for those two elements only the cos would add up, and also the field because of these two elements would be same in magnitude as this value only, but different direction. So what is seen is that for any element anywhere in the ring, there would be a corresponding element which is opposite to this element, such that even for this only cos would remain. So therefore the total field what we get would be adding all the cos component of each field. This is what is given here. Is equal to, we'll find what is dHL, which is k into dq by r square. If you use Pythagoras theorem, then r square is equal to a square plus x square into cos theta. From this triangle, this here is 90 degrees. So from this triangle, cos theta is equal to x by r, which is a square plus x square. So it will be x by a square plus x square, it's power half here, into power half. So into power half. Now from this we need to integrate it. Now we will try to pull out the common or constant terms. This k is a constant because k is equal to 1 by 4 pi epsilon naught. That's a constant that comes out. And also understand here that for every element distance remains same. It is x from here also. So for any element you take, even from here it is x only. Even from here it is x only. So for all the elements, distance of the element to the point P would be x. So even here x comes out. So what remains would be k comes out, x comes out, and here it will be a square plus x square power 3 by 2 into integral of dq. Now this basically means adding all the small elements. If we add all the small elements, then what we get would be the total charge capital Q. Therefore this is equal to, it is k x capital Q by a square plus x square power 3 by 2. So this is the expression for electric field. Now here, if you look at this carefully, in this case there is a net field along this direction. So if you call this as x-axis, this as y-axis, so net field is along the x-axis. So in vector form, if you write this vectorially, this E is equal to, it will be k to x by a square plus x square power 3 by 2 into I cap. So this is the field in vector form. The question says, the second part says, also find the maximum field. Now to find the maximum field, we need to differentiate the parameter with some variable here. Now the variable here is x because the point P could be anywhere. It is not that the point P field remains same. That is, if you take a point somewhere here or here, field would vary. So we need to find the point where the field is maximum. To find that, mathematically we know that to find maxima, to find maxima is a common term. Maxima could mean maximum or minimum. Whether it is maximum or minimum depends on the second order derivative. But for our level, we just find the first order derivative. That is, we'll find what is d by dx and equal that to 0. So we'll differentiate this part. So d by dx of k q x by a square plus x square power 3 by 2 is equal to we first differentiate any one term. So kq comes out. We'll differentiate the bottom term. It will be d by dx of this becomes a square plus x square power minus 3 by 2, and then plus we'll keep x as it is and differentiate. We'll keep system as it is, that is x square plus a square 3 by 2 as it is, differentiate with respect to x. If we do it further, then what you get here would be, it is k q x as it is. This would give us, should be minus 3 by 2 into a square plus x square minus 5 by 2. We know that d by dx of x power n would be n into x power n minus 1 into d by dx of the variable. It will be again differentiating this term alone. To differentiate this alone again, it will be 2x. So into 2x plus we keep a square plus x square. Oh, it will be the, okay. It will be here in the denominator. Just correct it. This will be minus 3 by 2 here. Keep it as it is, and what you get would be here x square plus a square minus 3 by 2. Differentiating with respect to x would give us 1. It will be 1 itself. Now the whole thing is equal to 0. Now from here you can cancel 2 and bring this term to right to this side. Then what you get would be, even kq would be 0. So there's 3, there is x square. So 3x square, and then write this as a square plus x square minus 5 by 2 is equal to a square plus x square minus 3 by 2. From here 1 minus 3 by 2 gets cancelled. So what remains here would be, it will be 3x square. To bring this side, it becomes a square plus x square. Whatever is done here is only high school arithmetic. So bring x square this side. So 2x square is equal to a square. Therefore x is equal to plus or minus a by root 2, which means at a distance of a by root 2. So a by root 2 on this side, somewhere here or here, a distance of a by root 2, and again a by root 2, the field remains maximum. To find what that value itself is, to find what is E maximum, we'll put the value of x in this expression. So to find E maximum, that is E maximum is equal to, the expression was k q x by a square plus square into 3 by 2. So it will be k q x was a by root 2 divided by a square plus x square was a by root 2 the whole square, this whole power of 3 by 2. That is equal to k q by root 2. This becomes 3a square by 2 power 3 by 2. That is equal to kq, this goes on top, it becomes 2 power 3 by 2 by, that is root 2, and you can write this as 3 power 3 by 2 into, this term would be a square power 3 by 2, and 2 gets cancelled, so it becomes a cube. There is a here, there is a here also. So this a and this one term gets cancelled, and also from here you can cancel root 2. Root 2 with this 2 gets cancelled. So what remains would be E maximum is equal to, it will be 2 aq by 3 root 3. I am breaking this term into 3 into root 3 into a square So this is the required value. We recall that K is equal to 1 by 4 pi